Earth science is a really cool science. Just saying. This Norris teaches science with another Earth Science Edition video. We're still talking about the lithosphere here. Mr. Norris is your presenter, and today I present to you earthquake dangers. So I can describe dangers and damages that earthquakes bring with them. So um, the first thing we talk about before we talk about the dangers and the damages, we're going to talk about the scales that we give earthquakes a value to. And there's three scales. You have the Richter scale, the moment magnitude scale, and the Mortality intensity scale. So the Richter scale measures magnitude, basically the size of the waves. It's usually based off the amplitude of the largest seismic wave, and it's a 10-fold system. So if it's a 2 on the Richter scale, it's 10 times stronger than a 1 on the Richter scale. And that's how it works, going up to 10. The moment magnitude scale looks at amount of displacement along the fault zone. It's more precise and it's most widely used because it also estimates energy released. If you look on the picture over here, we have on one side earthquakes, notable ones, and on the other side, talking about energy equivalent, like the Hiroshima atomic bomb. And a lot of earthquakes that are notable have more energy in them than the atomic bomb did. The Mercalli intensity scale looks at damage that occurs depending on the strength of the earthquake, the distance from the epicenter, you are the nature of the surface material, what your material you're built on, and actually the design of the building because the design factors into if it can withstand an earthquake. So if you look at the scale, you have one that's not felt, while a 12 that means everything's like destroyed. Now, earthquake hazards, or these are the dangers from an earthquake. You have seismic vibration, liquefaction, tsunamis, landslides, fires, foreshocks, and aftershocks. And we're going to talk about all of them. So, seismic vibration is the first one. This does damage the buildings, and it's based off how about the vibration that is released from those earthquake waves. And so the intensity of the vibration, how much vibration is there, is going to factor into the damage to the buildings, and how long the vibration happens can factor into the damage to the buildings as well. The type of material you're built upon. Some materials are easily can withstand the movement of the earthquake, while some does not, and it fractures too much. And then the design of the structure. Um, Places that get earthquakes a lot have different requirements for their buildings so they can withstand earthquakes. And some have actually, some scientists and engineers have started making buildings that can withstand stronger earthquakes by how they are built. Go over to Google, check out some earthquake proof buildings. That's what you can Google. And you can actually see some videos and some designs of how they're trying to make some of these buildings to withstand an earthquake. Liquefaction, this is when stable soil turns into a liquid. What happens here, you have soil, as the vibration happens, it kind of gets water saturated, and then the soil cannot support the structure, and some of the structures collapse. You have tsunamis. These are large ocean waves. How a tsunami works is that there's an earthquake, usually happens underwater, but sometimes a volcano or some type of push of the water can happen. And the wave comes and pushes along the shore. There are warning systems that we use to actively monitor if tsunamis are out there, buoys out there that can look at different wavelengths and give a warning, especially if they notice that there's been an earthquake nearby, because we do have a system to monitor for earthquakes as well. One thing I do want to mention, it is not like you would see in the movies where it's this big, giant, towering wave coming over you. You're looking more like a push of a whole bunch of water into land. And sometimes when it happens, there is a retreating of the water. That's a sign to run for the hills, not go get seashells. And that's one thing that happens sometimes with these tsunamis. Vacationing tourists see the water retreat, they don't really know what's going on, and they go and look at the newly exposed shoreline. The locals know what's going on, and they're running for the hills. You have landslides. These are greatest damage to structure because of the vibration. It loosens the soil, and the soil can just um, go down the hill. And then you do get fires. What happens here is there's ruptured gas lines and then a spark to ignite it, and you get fires everywhere during an earthquake, right after the earthquake. And then something called foreshocks and aftershocks. Um, Sometimes before a big earthquake, we get these little small earthquakes saying, "Oh, it's about to happen." And then after the earthquake, the soil just doesn't, the ground doesn't just settle into its new position right away after the earthquake. Sometimes there's small little adjustments, so you get these little small quakes after a big quake. But that's a little bit about the dangers that an earthquake can pose to society. I hope you learned something today. Go check out Google for those earthquake-proof buildings or ones that can withstand earthquakes. And this is Mr. Norris, and I'm out for this video.